The National Cartographic Information Center, NCIC, is responsible for organizing and operating a public and private network for cartographic information. NCIC is operated by the Topographic Division of the U.S. Geological Survey. Its main office is located at the Survey's National Center in Ruston, Virginia. Part of NCIC's mission is to collect and distribute information describing aerial photographs of the United States, its territories, and its possessions. Here is one example. A vertical aerial photograph showing San Francisco, its bay, and the Golden Gate Bridge as they appear from an altitude of about 60,000 feet. Other photographs show the Florida Keys, part of the Mississippi River, a national forest, a desert, or farmlands. And there are many different types of photographs. Some are taken from very high altitudes and cover large areas, while others are taken at lower altitudes and show smaller areas in greater detail. For example, this close-up look at a section of Phoenix, Arizona. The photographs are taken by special cameras in planes like this, using different types of film. This example shows the same agricultural area as it appears on color, black and white, and color infrared film, each giving us a different insight into the land and its features. Presently, there are probably well over 40 million photographs in existence, enough to make a stack higher than any mountain in North America. Until recently, the search for just the right photographs was a difficult one. Beginning in 1974, NCIC set out to gather information about the nation's aerial photo projects. Today, the information on this mountain of photographs is contained on just one reel of computer tape, organized so that you can identify which project has the coverage you may find most useful. The system that was developed to store this information and make it available to the public in a useful form is called the Aerial Photography Summary Record System, APSRS. APSRS is a computerized file of information about the aerial photographs held by many federal, state, and local agencies and private firms. Agencies willing to have information about their holdings entered into the system are called contributors. APSRS describes numerous aerial photo projects for almost every part of the United States. Projects flown at different scales, with various types of film, and collected by many contributors over the last 30 to 40 years. At present, the system contains records on about 3/4 of the most useful aerial photo projects that are available in the country today, and we are constantly seeking out additional data. Information in APSRS is sorted and displayed in printed catalogs, on state-based graphics, on computer output microfiche, and on standard computer printouts. The APSRS catalogs, updated periodically, contain tabular and graphic maps which show photographic coverage of the United States for different time periods and at different scales. A closer look at the map shows that the shading is actually a combination of letters and numbers. Each character is a code, indicating the contributor who holds the most recent photographs of a given area. An address index then shows you which contributor you can write to, call, or visit for further details. This information can also be displayed on state bases using a series of computer-generated state graphics. The catalogs, or the state graphics, are very useful, but they cannot provide answers to all related questions. For example, the system will not direct you to a specific frame of photography which shows your house, but it will identify who holds the coverage that might best meet your needs. In other words, APSRS helps you select photo projects, but not single frames. To provide you with important detailed information on the individual photo projects, NCIC has produced a series of computer output microfiche. The entire aerial photo project database can currently be stored on approximately 100 microfiche. This is an enlargement of one frame, or square, of that fiche, which shows the format for displaying all the information contained in the computer for each project covering your area of interest. It lists the geographic coordinates for the area, the state and city codes, collecting agency, scale of the image, and so forth. Using the paper and microfiche catalogs, NCIC can answer most inquiries. But there are often other questions that require in-depth research. Suppose, for example, you wanted to know what coverage was available for the Lake Michigan shore area that meets all of the listed requirements. Such a request would take hours of manual searching to come up with the answer. But the NCIC information specialist can initiate a computer inquiry to automatically obtain the information. And that is APSRS, a computerized record-keeping system of information about the nation's aerial photo projects. Now let's look at how this information gets into APSRS. Each contributing agency prepares information describing its photo projects. These records, called summary records, are first prepared on a code sheet like the one shown here. The procedures for preparing the code sheet are explained in detail in a contributor's guide. The forms are called code sheets because the information usually is entered as number and letter codes instead of writing it out in longhand. For example, if you're describing color photographs, a 3 is put in the space under film type. For black and white, a 4 is used, and so forth. The summary records are prepared to cover a group or mosaic of photographs rather than an individual one. Thus, one record can describe several aerial photographs. To be described as a single record, all the photographs must be alike in the ways shown here. The last item on the slide, geographic formats, needs further explanation. The first geographic format for entering data is the county format. In this case, the FIPS code section of the sheet is used to identify the county. FIPS means Federal Information Processing Standards, a set of standardized codes and terms used to record and process information. In this example, the 51 under state means that it's in Virginia, and the 059 under county shows that it is Fairfax County. The other two acceptable formats use latitude and longitude to identify the area covered. Latitudes are the east-west lines you've seen on maps and globes, and longitudes are the north-south lines. Both are numbered in degrees, and, like the hours of the day, can be subdivided into 60 minutes and seconds. To identify any point on the Earth's surface, you merely give the numbers for the latitude and longitude lines which intersect at that point. That pair of numbers is called a set of coordinates. With that in mind, we can now describe the second format called the quad format, which is a column or tier of quadrangles that are each 7.5 minutes, 1/8 of a degree, of latitude high, and 7.5 minutes of longitude wide. This format is called the 7.5 quad tier. One such quadrangle is shown on this slide in relation to 1 degree or 60 minutes of latitude and longitude. The column must always run south to north. It can be many quads high, but only 1 quad wide. You identify where the tier starts by giving the coordinates, the latitude and longitude, of the southeast corner of the entire column. That coordinate is entered in degrees and minutes in the space provided. In the next column, you enter the number of quadrangles in the tier. And that's all there is to the second format. The final format is called the four-corner format. It is used to define an area of any size or shape that is bounded by 4 straight lines. Some examples are shown here. In this case, a second code sheet must be used to give the coordinates of all 4 corners, since there is not enough space on the first sheet for that purpose. To summarize this part of the presentation, then, in order for photographic coverage to be entered into APSRS, it must be described in one of the geographic formats shown here: county, 7.5 minute quad, or 4 corner. A final word regarding these formats. Remember that you must also insert a code indicator under report type to show which of the 3 formats was used to enter your photographs. There are two other fields on the code sheet that are particularly important when encoding. First is the status field shown here. APSRS not only has records of existing photographs, but it also has records of projects that are planned or underway. The code entered here indicates that status. This information is useful to agencies or private organizations who are scheduling aerial photo projects. If existing photographs can be purchased by a second or third party, money and time can often be saved. The other critical information field is the action code. So far, we've only discussed adding new records. However, contributors must sometimes make corrections and changes to existing records and delete others from the files. This action code indicates whether the record is being added, deleted, or modified. The remaining fields on the summary record code sheets contain the following additional information about the photo projects. Now, because people do make mistakes, we must also look at the editing and correction process involved with APSRS. NCIC edits all inputs. The computer finds two kinds of errors, non-fatal and fatal. A non-fatal error is a minor error. For example, an 18 under month of coverage must be wrong, since there are only 12 months in a year. A Q under film type is also wrong, since the instructions state that the numbers 1 through 5 should be used. When the computer finds such errors, it generates error messages that include statements as shown. A fatal error, however, is one that makes the record virtually useless. Leaving out the code of the contributor is an example. What use is a record of aerial photographs if you don't know which contributor holds them? Similarly, a fatal error occurs when the report type shows coverage of a county, but the Phipps County code is left out. The error messages shown here indicate which actions were rejected and why. There are many other errors caught by the computer, and each has its own distinctive error message. Once the error messages have been produced, the sheets are sent back to the contributor, who must then correct the records. Of course, the action taken depends on the type of error and whether or not it was a fatal one. The correction of errors by contributors is a vital part of the system. Without it, APSRS could not be an error-free, up-to-date information system. Still, there are also a number of errors that the computer cannot catch. To illustrate, let's go back to the code for date of coverage. You saw that an 18 under month must be wrong, since there is no 18th month in the year. The computer would catch that error. But what if the photographs were taken in August, the 8th month, but a 2, meaning February, was entered by mistake? Either of those dates could be right, so the error is not an obvious one, and the computer cannot detect it. Similarly, regarding film type, there is no film type Q, but there is a 3 and there is a 4. If the photographs are color, but a 4 is entered by mistake, the computer will accept the error because it could be right. To catch mistakes missed by the computer, each contributor is also given a computer printout that shows how his transactions were processed by the computer during each edit and input cycle. The contributor is asked to check the printout against his own records as the final step in the editing process. One final point about the actions we've been discussing. The code sheets used to prepare them cannot be fed directly into the computer. The information must be transferred onto punch cards or magnetic tapes before the computer can edit and process the information. So please make sure your submissions are correct and have been checked before sending them to NCIC. And that is APSRS, a computerized record-keeping system of information about the nation's aerial photo projects. If the computer is the heart of the system, the summary records are its life's blood. So those of you who supply the information play a crucial role in helping us answer thousands of customer requests. Please contact us if you have any questions about the use of the system.